What are the steps in finite element analysis? You are nearly ready if you are familiar with the general form of Hooke's law, which states that for small deformations of the object, the amount of deformation or displacement is directly proportional to the deforming force or load. The constant of proportionality in the above equation is the stiffness of the object. Generally, the stiffness of the object is known since we would have its shape and material properties as a given. If not, either we would be optimizing its shape by finding stresses generated in the object due to applied loads. For example, objective of the study can be to optimize web thickness of gussets or optimize thickness of a pressure vessel nozzle saddle. Or we would be checking which material is most suitable for the given object. For example, objective of the study can be, can aluminum alloy be used to reduce the weight of the object while keeping the stresses within limits? So, stiffness K would be fixed for the given analysis based on shape and material selected. The next step is boundary condition. Any given object must be sufficiently supported in the real world, and finite element analysis will simulate these supports. Either there are fixed supports, example bolted or welded joints, sliding supports, example shaft in a hub, or pipe shoe on a structural steel. By applying these boundary conditions of support, we are providing fixed values of displacement. Then there would be forces applied to the object, either by gravity or self-weight, or by pressure applied on the surface, or forces applied on the object. By adding these boundary conditions of load, we are providing or fixing values of force or load. After all of the above is given to the finite element analysis software, it tries to solve the equation, which will be in matrix form with the given input values of displacement and forces, and obtain displacement for the entire object. These displacements or strains are converted to stresses. As we know, stress equals to strain multiplied by Young's modulus of the material for an elastic case. These stresses are then displayed as colored model, or they can be exported as a table. Next, we are going to see what are the steps in performing finite element analysis. In general, conducting finite element analysis has three basic steps. First is pre-processing, second is the actual analysis, and the third is post-processing, where we get the answers for the analysis. I would like to further break this pre-processing step into further 4 steps. The first step is to clearly define the purpose of the analysis. What are the outputs required for this analysis? What are the types of material? What are the types of load? We need to gather all the inputs for the analysis. This can be done by meeting with the client, or it will be given to you as a stress analyst before you start doing finite element analysis. The next step in pre-processing is creating the geometric model. This model can be a one-dimensional, two-dimensional, three-dimensional model, or it can be an axisymmetric or a shell model. This geometry can be created in Salome Meca's geometry module. The next step in pre-processing is generating a mesh file. These meshes can be a tetrahedral mesh, a hexahedral mesh, or it can be a simple thing as a shell or a beam element. Meshes can be generated in Salome Meca's mesh module. The next step is to combine all of the inputs and the mesh generated into what forms the part of the analysis. We need to define the type of analysis. We need to define the material properties. We need to define what are the displacements, if any, or if the displacements are fixed in a particular direction. We need to define loads and boundary conditions. We need to also define if there are any load combinations. All of this can be done in efficient software. It can be done using a text editor or as the study module of Salome Meca. The next step is running the analysis. This is done in Esther study module of Salome Meca. After you get positive results, or once when the analysis run is complete, you can post-process the result in Salome Meca's Paravis module, where you can find displacements, von Mises stresses, and or principal stresses. So, these are the steps in conducting finite element analysis in Salome Meca.